Welcome to springlib.
So to find out the oxidation number of sulfur in each compound given, what we have to do is we have to write the summation of the oxidation number of each atom or ion present in the compound, and that sum will be equal to the net oxidation number or the net charge on the total compound or the complex we have. So we start with the first one. Here we have barium sulfate, which is a neutral molecule. That means it has a zero net charge on it. Now we have to write down the summation of the oxidation state of each one. So barium, as it is in group 2, it will always have a oxidation state of +2. And if we let the oxidation state or number of sulfur as X, then we write X for sulfur. And then for oxygen, we have -2 oxidation state for each oxygen here, and we have four oxygen. That means -2 times 4, and this total sum will be equal to the net charge on the compound, and here it is 0. That means we have 0 in total. Now if we just solve this equation, we will have x plus 2 minus 8. That means x minus 6 is equal to 0. And if we just rearrange it, it will be x is equal to +6. So that means the oxidation state of sulfur in barium sulfate is +6. Now I go to the second one, where we have sulfurous acid, H2SO3. Same way we write down all the oxidation states. So for oxygen it is +1, and we have so for hydrogen it is +1, and we have 2 hydrogen here. That means we have +1 times 2. Then for sulfur it is X, and for oxygen it is -2 times 3. And since it's a neutral molecule, it has a 0 charge on it. That means we have 0. And if we just solve it, we have 2 plus X minus 6 is equal to 0. And ultimately we'll have X is equal to +4. So in this compound or sulfurous acid, the oxidation state of sulfur is +4. Now in the third one, we have strontium sulfide, SRS. So strontium is from group 2. That means it has oxidation state of +2. And sulfur, if we consider it X equal to, so being it a neutral molecule, the net charge will be 0. And that means X is equal to -2. That means in this compound, sulfur has an oxidation state of -2. And finally, we have H2S. So for hydrogen, it is +1. For 2 hydrogen, it will be ×2. Plus for sulfur, it is X equal to 0, the net charge. That means X is equal to -2. So in hydrogen sulfide, the charge of sulfur is -2, or the oxidation state of sulfur is -2. Now so in the next portion of the question, we have to answer, or we have to locate sulfur in the periodic table. So if we look at the periodic table, we can see that sulfur is located in group 16 in the modern periodic table, or it is located in the group 6A. So this group is called 6A in the older method, and in newer on the modern periodic table it is named as group 16. So sulfur is located in group 16 and in row 3. And the next portion asks us which region of the periodic table contains element that can add up both positive and negative oxidation number. So if we look at this periodic table here, only the green region, that means which is non-metals other than the noble gases. So other than noble gases, the non-metals, which includes these green compounds, green elements here, that is carbon, nitrogen, oxygen, fluorine, then phosphorus, sulfur, chlorine, then selenium and bromine, iodine. And here we have also hydrogen. So these green marked elements, or this region and this hydrogen here, all these green marked elements will be able to have both positive and negative oxidation numbers.